Hey everybody, I'm Matthew Devanesha. I'm a new computer literacy teacher here at Uni, and I'm also overseeing the Makerspace this year. So we have a lot of new things here in the Makerspace. So we have some new 3D printers. A lot of students have been using that to print various parts. Some of you have been using it for their Halloween costumes, others have been using it for their class projects. So that's been one of the most popular items. We also have a circuitry area where students are able to go in and create anything that involves Arduinos, Raspberry Pis, LEDs, and they just get a lot of really cool basic circuit experience. Some other things that we have in this makerspace that are really popular, we have our soldering iron stations where students can make more permanent electronic fixtures. We have a couple of robotic car kits that students can go in and practice that type of circuitry. And we also have sewing stations where students can make fabrics and get more practice with some of the automated sewing features that we have over there. So the last thing that we have in the makerspace is we have a vinyl cutter, and students can come in and create cool art projects. It's essentially just a knife on a rail, and it can get really detailed and really fine, and students don't have to do everything by hand that way. A lot of the students in our Computer Literacy 2 class are using this makerspace in order to make their projects. For example, we have a ping pong robot that a group is working on. It's just basically just shooting a ping pong ball, and people can use it to train and things like that. Another project that is in the makerspace is we have a group working on the type of jewelry where if you press a button, it'll send a friend or maybe the police your location. So that's really great, going on security there. Another project that we have going on in the makerspace is we have a group to having this live, this physical tic-tac-toe board, and they're using an Arduino to interface with a Python code in order to actually play tic-tac-toe on a computer using some physical pieces. Another group that we have is using our 3D printers a lot in order to make their own personal board game of Chutes and Ladders, a vertical style board game, and to just put a good spin on the traditional game. And lastly, we have another group doing a type of ghost piano. So they're using an Arduino to detect whether some flex sensors are being bended and crushed. And then they're using that in order to make piano sounds on a circuit that they're building right now. So it's a lot of brilliant students working on creating some fun and neat projects that they're learning a lot from. And in addition to those, we have some other students working on some other projects that are involved in STEM and engineering, particularly students working with some professors at the U of I as well.
So we're currently building a fresh bar printer at our school, which stands for Freeform Reversible Embedding of Suspended Hydrogels. So basically, you're extruding an ink made out of hydrogel into a support bath of ground gelatin. And that ground gelatin acts like a mold that holds the hydrogel in place so it doesn't melt away or anything. It just hardens in the exact same shape as it was extruded. So we started this project because first, we started out by participating in this soft robotics program. Guided by Mr. Bergendine, who was our chemistry teacher, and Dr. Galecki from the UIUC in the Harvard research team, including Sapna Shah. And after the program, we were really passionate in soft robotics, but we were also interested in tissue engineering as well as 3D bioprinting. So we reached out to Dr. Galecki, who was also helping with the soft robotics program, kind of talking about our passions. And then she recommended us to build or actually read about fresh bioprinting. And we thought it was super interesting because fresh bioprinting is really making bioprinting much more quick and high quality. So we wanted to make it accessible to students at uni. So that's why we started building it. And yeah.
So currently we have the extruder done. So this is all 3D printed. We took the files from the article that Dr. Galecki had sent to us. So how it would work is that this would, let me move this a bit. This would go on top here. Oh, it would go on top here, so we would have it connected, obviously, and connected to the computer, the screen there. And this would move sideways. This printing bed would move up like this. And the soft material would go into this syringe here, which would extrude the material into the support bath that would be over here. So this is what we have done so far, and we're currently connecting.
Yeah, so we're currently connecting this thing called a Wi-Fi Panel Due 5i board, which is like a touch screen. You can actually touch it and control it like this. It makes a sound, kind of cool. So you can actually change the printing parameter, like how fast the nozzle moves around, how much it extrudes, and everything else by just simply touching it around. And also you can send 3D printing files like STL files or G-code so that the file can be printed with our BioPrinter directly. So we don't need an SD card, blah, blah, blah. We just can send it through Wi-Fi, because this board right here is actually connecting our computer to this BioPrinter, and also connected to this one. So like we can control it in 2 ways, so that the BioPrinter prints whatever we want and however we want it to print it.
This project was for students to build catapults. It was during our quadratic equation unit. We were working with standard form, vertex form, and factored forms of quadratic equations. So students were tasked to build a catapult, fire something, and then evaluate the trajectory with those quadratic formulas. So they would first find the vertex and plug it into vertex form, translate to standard form and factored form if they were able to. And it was just to give students kind of an idea of how quadratic formulas are used in a STEM sense.
For this assignment, we had to create a catapult to learn about and measure parabolas, and we wanted ours to be llama themed, so we went really big and created a llama themed catapult.
In the summer of 2020, I decided to do the Carle, Illinois College of Engineering Health Makeathon. I had seen it the previous year, and so that inspired me to enter my idea, which was really just sitting in a notebook in the bottom of my drawer for many years. And so my idea was a smart security pill cap and app to help alleviate the opioid crisis. A lot of the times when we look at addiction, we see it as a moral failing rather than a disease. And so I really wanted to make a product that would focus on patient accountability and give the patient control. So this cap isn't a lock cap. It's simply a cap that can just keep a record of how many pills are being taken out within a certain time frame. And so what that does is it gives a provider more information as to how the pills are being used or how the prescription is being used, because providers don't know anything about that right now. And so what that will do is hopefully open up a conversation between patients and providers and make that relationship more, honest and open. And so I became a finalist, and I did my final pitch to the Shark Tank to the Dolphin Tank when I was a rising junior, and I won. So I was paired with Dr. Holly Galecki's bioengineering class at the university, and I developed one iteration of the PillSafe prototype. At the same time, I worked solo at the fabrication lab and developed my own iteration of the PillSafe cap. And currently I'm working with the electrical engineering class to develop an app. So we have 2 prototypes, we're working on an app, and hopefully I will do a final pitch and create a startup company with this.
So we did 2 projects with VR. We did one project where the students created historical artifacts, and they use the VR to kind of like experience the artifacts in real time. So, for example, one group made a Sumerian ziggurat, and they were able to put that to scale and then like experience it in like real time. The other project, the students used these pilgrim narratives, or like travel narratives of people from like the late Middle Ages to early Renaissance, and they use those narratives as like to give a tour of a place in virtual reality. So they went to places like Rome or Jerusalem or Mecca, and then gave their classmates a tour of that place in VR using these like primary sources for the class. So the technology helped them for the first project get like a sense of scale. They're able to kind of like experience these things in a way they would not be able to experience them otherwise. And they were able to, get a kind of spatial feel for things. So like with the VR and Google Earth, you can go to like Street View, you can go to like the streets, right, of Jerusalem and walk around and see the buildings, and like you get a sense of like how the actual space is and how people may have moved through it and like operated within it. So it's a really nice way to kind of like help the students experience historical topics in like a way they wouldn't otherwise be able to.
Thanks for taking a look at engineering at Uni High. We're looking to expand the functionality of our makerspace, getting technologies like laser cutters, having a more permanent VR fixture in here that students can use. And yeah, so if you're ever around, feel free to stop by, and we appreciate all your support.